All right, graphing rational functions. A couple of things to be aware of right away. You're going to get a basic form. Just like before, if we're in the parentheses, that's going to be my right and left shift. And just like it was before, typically when we see the ones in parentheses, it's going to be the opposite of what we would think. Left would be my plus, okay? Right would be my minus. And my one on the end here is basically going to be my up and down. Now, I'll admit, with these, we're probably going to be doing more work with the calculator and using the table, and you'll see why here in a minute. But we want to have a general idea of where some of this is coming from. Okay, so there are some similarities with the graphs that we've done before. So if I go to graph 1 over x, now I could go ahead and just plug this in the calculator and go, woo. I mean, that would be fine. But I mean here, if I plug in my values, you're like, okay, 1 over x, so it's 1/4, 1/3, 1/2, 1. Before you peek at the calculator for that last number, though, really think about it. What's 1 divided by 1/2? 2. So you start to look at these values, and you're like, okay, so if I plot these, it's kind of looking like what we did when we did growth and decay, because it kind of looks as though this is just going to curve down and hug here, and you'd be right. Ooh. 1 over -4 would be -1/4. All right, so this looks like it's basically going to be the same. And no, you aren't going to need to plot 10 points for every one of these. We're going to find a way where we start to see a pattern develop, and that's going to make this a whole lot easier to deal with. So we'll get those plotted. This is just a base graph for us to work off of, basically. Okay, so I get those plotted. Notice I'm not connecting them yet because I want to see a couple of other things here first. So I notice, and this would be a good time to bring our graph up for this. Because if I go and put this in, and again, I'm just putting in this 1 over x that you have here. And I graph it. Now see, this is what stuck some of you, even when we were doing the test before. Just because it looks like this is stopping here, or stopping here, doesn't mean it is. It's hugging that asymptote, and it's just going to keep on going. So in our case here, we're going to be right up against the y-axis and then right up against the x. And the same thing here. So these look a little different because not only am I getting one that looks like growth and decay, but I'm getting a couple of them. And that's going to be the case with these. When you get one that works like this, okay, where you've got your two curves, we'll give them a specific name here in a minute. It's called a hyperbola. Okay, not a hyperbola, but just a hyperbola. Yes. And I'll come down to here, and then we'll come back up here in a second. Get that out of the way. Okay. It's always going to have two parts that are symmetrical, and those are called branches. And that's what I'm going to refer to them as from here on out. I'm not going to call them curves. We're going to actually call them branches, because that's the proper name to use. So here's how this is going to work. On a typical base graph of these, notice my graph not only hugs this line, and I'm going to put a dotted line in here to signify that's kind of a wall of sorts. It's an asymptote. We talked about those before. The y-axis is our vertical asymptote. Okay? Also could be called, excuse me on that one, x equals 0. Okay? Because my x value is 0 no matter where I go up and down this line. When I also notice that my graph hugs up against the x-axis. So most of these graphs are going to have two different asymptotes. The x-axis is my horizontal asymptote, and it would have a value of y equals 0, which is strange because you like the x-axis, it's y equals. But that's, again, because my x values will change as I work through here, but my y values won't. So that's what a basic hyperbola is going to look like. Your domain and range are all real numbers not on the asymptote. So you're like, okay, so what exactly does that mean? What that means here is when I go to do my domain and range, if I was asked to do that on this first one, my graph goes forever to the left, my graph goes forever to the right. What one value will it never touch? 0. So my domain is going to go from negative infinity to 0. Got to be a parenthesis because 0 isn't included. And this is going to seem strange. And then it goes from 0 to infinity. That's how I write an interval notation. I want all the real numbers except my asymptote, which in this case is going to be 0. In my base graph for range, the same thing is going to happen because it goes up, up, up forever. It goes down, down, down forever, but it's never going to cross this point. It's 0. So my range actually ends up being the same thing. So whenever I have movement, up or down or left or right, that's going to change those values. But it's whatever the asymptote is. The asymptote goes directly with my domain and my range on that. So just something to kind of be aware of. So if we actually get to play with one from the start here, a couple of things we want to keep in mind. First, what would my shifts be for this first one that we're going to take a look at?
Left 3, down 1.
Okay, left 3 and down 1. Now let's kind of keep this first one in mind. So we got 2 divided by, notice I'm putting parentheses with my x plus 3. Anytime you have a binomial term, anything with a plus or a minus, especially if you're putting it in the calculator, you've got to have the parentheses or you will not get the graph that you're looking for. So when I graph that, notice a couple of things happen. It looks like, and they'll draw the asymptote in for you. This line that you see right here, this is not part of my graph. This is me seeing where the asymptote is, my vertical one. So, for instance, here, I shifted my vertical asymptote left 3, just like I saw here. It also shifted, notice I'm not hugging the axis anymore for x, it's 1 below that. And I'm going to be able to see that visually, but also when I bring up my chart, something else I'll start to notice. Wherever you see the word error, that's your vertical asymptote, or asymptotes in some cases. Okay? So when you see error in a y value, that's going to be a vertical asymptote. You're like, okay? So here, and I'd know that just by my shift, because if it's originally at 0 and I move it left 3, it'd be at negative 3. I mean, that makes sense. So when it asks me, you know, where are the asymptotes, here's the thing again that's tricky. Vertical asymptotes are x equals. You're like, but the y value is error. I get it, I know. But that means that's where the spot that my y value can't be for this one. So I've got an asymptote at x equals negative 3. And the good thing about drawing these in before you graph is, if you tend to get sloppy and just draw a line, you don't care where it goes, this is going to be your wall. This is going to say can't go through here. So then my minus 1 being down 1 means my horizontal asymptote is my y equals is at negative 1. So whenever you're doing these, always a good idea to draw your asymptotes in first. Because once you have those, my general rule of thumb when it comes to graphing is you need 2 points on each side of your vertical asymptote if you're going to graph it. So in our case, okay, there's my vertical asymptote at negative 3. I'm going to plot those 2 points to the left. So negative 5, negative 2, and negative 4, negative 3. So we'll get those in. And then on the other side, at negative 2, my value is 1. And at negative 1, my value is 0. And if you want to plot more points, you can. Feel free. Uh-huh. Looks weird. Is your table normal?
I don't know.
Well, hit table and see if it looks normal.
It's like negative 2.000.
Ah, okay. That's something, try to ignore it for just a second. That's an easy fix, but I'll grab it here in a minute. And then I can just connect those dots. But remember, these are hyperbolas. There's a curve. Okay, it's not just a straight line. So we're going to approximate with these, but we're going to use those 2 dots sort of as my guide as I go to draw it in. So, once I get that drawn, let's try to make some connections here with some things. So when we talk about A, okay, A is the number in the numerator of my fraction. In this case, it's just 2. If that value is positive, okay, if it's greater than 0, you're going to have your branches in quadrant 1 and quadrant 3. Now, if you haven't had a lot of experience lately with quadrants, they go kind of in a C shape. We start in the upper right-hand corner and we just work our way around. So quadrant 2, quadrant 3, and quadrant 4. And just having this value helps me to see. Maybe I type something in wrong sometime, and like in this case, they end up in quadrants 2 and 4. And I'm like, wait a minute, they're not supposed to be there. What's going on? Oh, and it kind of helps me. If it's a negative A value, so like if this had been negative 2, my branches would be in quadrants 2 and 4. Okay. They're always going to be at a diagonal from each other. They're not going to be right next to each other. Okay. And then A itself determines the width of my graph. Okay. The bigger the number, the closer it tends to get to the asymptote. The smaller the number, the further it tends to get away. And then we already talked about the shifts up above, but we'll just kind of make note of them here again. The H value, again, is my left and right shift. Again, left if it's plus, right if it's minus. This has a direct correlation to my vertical asymptote, again, which is my x equals. Because you notice here, left 3 shift, asymptotes x is negative 3, okay, directly connected to each other. The k, the value that's hanging out all by itself, is my up or down shift. That directly connects or correlates with my horizontal asymptote, or my y equals. Y equals -1 because I shifted down 1. Okay, they go together. There's lots of connections in this, and once you start to see where the connections come from, you would be able to take this problem, tell me the shifts, and tell me the asymptotes, and what branches are in what quadrants before you ever touch a calculator. The calculator, that's just some mini stuff, plot 2 points and connect the lines. If you understand this, it makes this fairly easy to work with. Fairly easy. I never am going to say something's totally easy because everybody's got their own way with things. Okay? Now this part up at the top of the next is just saying that there is similarities with what we've done before and how the shifts work. We kind of talked about that through the first page. So that's not as much of a big deal. It's just explaining left, right, up, down, which we just did. So when we get into doing some of the practice with this, okay, so we're going to graph a couple of these. And then I just want to do some general work. But let's see if we can do some of this without doing the graphing right away. So let's just play with 1 and 2 here for a bit. Okay. First thing. What are my 2 shifts in number 1?
Right 2, up 1.
All right. Right 2 and up 1. At this point,
We have to write down shifts every time.
no. But I'm just trying to get some of you to connect these things right away.
Alright.
So my vertical asymptote always has to do with my left or right shift. This directly correlates to that. So if I start at 0 and I shift right 2, my vertical asymptote will be at x equals 2. So you're like, so basically you're just saying whatever this is, you just do an opposite. It's almost like setting it equal to 0, and it is. And I'm going to draw that in right away. So then I look at the horizontal. Yes, the horizontal directly correlates to this number on the end. So if it shifts up 1, it's y equals 1. Get that dotted in there. And at this point, all I'm going to do to get some points, now I could just do this even with mental math if I wanted to.
Mental math.
2 points to the right, 2 points to the left of my vertical asymptote. But if my brain is out to lunch or I just want an easy way of having things go, I can always put this into the calculator. Again, remember the parentheses. Whenever that plus or minus comes in, whenever you have a binomial, make sure the parentheses are in there. So make sure everything's typed well, looks good. And I'm just going to make sure, actually let's look at the picture here for a minute. Okay, it's sensible. Here's my vertical asymptote. Looks like my horizontal is above the x-axis, which would go along with what I have over here. So now I can just say, okay, so 2 is the magic number here. Okay, there's my error. So I want 2 above my error and 2 below my error, because that's right around my asymptote. So at 1, I'm going to have 0. And at 0, I'm going to have 0.5. So we're kind of tight to the asymptote here. Make sure your graph goes off to infinity in both directions. Don't just stop or make some little tiny curve here and no arrow. We're going to be detail-oriented. Then we move to the other side where x is 3 and 4. Just a couple values to the right. So at 3, we've got 2. And at 4, we've got 1.5. So again, really tight. My branches are in 1 and 3 like they're supposed to be because the 1 is positive. So there's all these little pitfalls that I can avoid if I just understand some basic general stuff. So let's see, do we want to do that one or that one? Let's do 2. Actually, I got something better even. Let's just go into vertical and horizontal asymptote craziness. Because if you've got this info, like I said, you're just going to plug this part into the calculator to get your values. So as long as I know how to find my asymptotes, this should be fairly simple. So all right, let's correlate again here. What are my shifts in number 2?
-2.
That's one step ahead. Okay. Left 2, up 3. So what does that mean for my vertical and horizontal asymptote?
-2.
Okay, -2. Because again, this correlates with this.
Y equals 3.
And y equals 3. So I get that popped in here. Get this guy popped in here.
You have to mental math again.
Because what you could do is basically do substitution in your head on these. So like for instance here, -2, I've got -1 and 0. Well, I can plug in, okay, -1. -1 plus 2 is 1. 1 divided by 1 is 1. 1 plus 3 is 4. Because I'm going to get the same thing.
So I just plug in -2.
Yeah, you're just plugging in values. You're doing the exact same thing that the calculator's doing when you do the mental math on these. So it's not like you'd have to have a graphing calculator to even graph these, to be perfectly honest. Let me take a look, make sure everything's looking okay. And it does, because if I shift this over, there's my vertical asymptote. There it is here. And again, it looks like it's shifted upward. So I'm feeling good. Again, my vertical asymptote's at -2. So find the error message. And then we're going to plot 2 above it. And we're going to plot the 2 numbers that are right below. So at -1 and at 0. And again, expand those hyperbolas. Expand those branches. Would it take me longer if I just did a mental math in my calculator? Probably a little bit. But again, just plug in a simple number in for x, you can get the values if you really needed to. So that's what's going on here, okay, with the graphs. So I'm hoping this whole idea of understanding the asymptotes is going to help us with the graphs. But just in case, we're going to get a little more practice with the asymptotes. Here we go. Okay, no calculator needed. State the horizontal and vertical asymptotes, then state the domain and range. You're like, oh, geez. All right, we got this.
Is it another worksheet?
I am going to stress on this. Horizontal asymptote, you've always got to have y equals. Vertical, you have to have x equals. You can't just put a number because I want you to show me that you know what the equation of the line is. So, I switched up the order, so be careful. What's my horizontal asymptote going to be in number 1? Y equals -1. Vertical? Close. +4. Because again, it's an opposite on that. And here's the other thing where you get to see one more connection. Your horizontal asymptote and your range go hand in hand. So when we talked before about the negative infinity to infinity except where that one value is, that's exactly how this works. So from negative infinity to -1, and then we reconnect it right afterwards. So we're including every number except -1, but we're putting it in interval notation. Domain, you'll never guess, goes hand in hand with the vertical asymptote. Same idea, except now it's that x value, which makes sense because the domain is my x values anyway, so it makes sense that the x equals equation goes with domain. Range is my y values, so it makes sense the y equals equation goes with that part. So one more here. Let's make sure we've got this. We won't go into overkill. Let's see, number 2. What's my horizontal asymptote? 2. Whatever that value is on the end. What about vertical? -3, because again, it comes from here, but the idea is that it's x minus h, so I have to look at its opposite. And then again, just make the connection. Vertical goes with domain, because it's my x's. So my only gap is at the -3. Range goes with my horizontal asymptote. So my only gap will be at 2. Okay. One last problem, because I want to introduce part 3 today, because there's one thing on the homework that I want you to be able to tackle, but we're going to get more in depth tomorrow. There's one more type of function we can deal with. It's called a rational function. The ones we did so far were simple. Okay? Now this is more of your generic or your regular. So here's how this works. We're going to add a couple of things. Our x-intercepts we're now going to look for are the real zeros of p of x. Here's what that means in English.
This sucks.
Set the numerator equal to 0 to find your x-intercepts. Okay, because p of x just is my numerator. My vertical asymptote, okay, when these change, when it's no longer just a number up in the numerator, but now there's variable terms, we're going to find our vertical asymptote by setting the denominator equal to 0 to find my x equals. So again, if it's just a number like it was up here, keep using the same rules. We're just going to use those two things to tell me. But once you come down here and you start getting variable terms here, that changes things a little bit. And then the horizontal asymptote is found by comparing the degree or the exponent that I have. And of course, there's 3 possibilities. We have nicknames for them all. If something is bottom heavy, it means the degree in the denominator is larger than the degree in the numerator. For instance, if I had x squared over x. Oops, no, it's just the opposite of that, Hardy. Mercy. The degree in the denominator is larger. 2 is bigger than 1. Or if you had x to the third and x squared, 3 is bigger than 2. Then it's just y equals 0. And you'd be able to see this if you plugged it into the calculator anyway. If it's top heavy, just the opposite, and the exponent in the numerator is bigger, there is no horizontal asymptote, but there is an oblique. I will talk about obliques tomorrow. We're not going to get into that now.
They're on the sides.
And then equal weight means you've got the same in the numerator and denominator. In that case, the horizontal asymptote is the ratio or dividing the lead coefficients. So here's how this will work. We're just going to do some basics here. Okay, x-intercept, if we look up, we'll set the numerator equal to 0. So if my x-intercept, I just set x plus 1 equal to 0, I have an x-intercept at -1. So there's 1 point in my graph. My vertical asymptote I find by setting the denominator equal to 0. Yep, add the 4, divide by 2. My vertical asymptote Is it 2? X equals 2. Cool thing with all this is we're going to be able to check it on the calculator. The horizontal asymptote, they're equal weight because my exponents, my degree is equal. So you just divide their coefficients. Well, there's a 1 in front of this x, so 1 over 2. You're like, ooh, they can get to be fractions?
Negative
Oh, yeah.
Negative order.
No, 1 over 2.
Why?
Because I'm just dividing the coefficients. Neither of my coefficients are negative.
Gotcha.
Okay. When I'm looking for horizontal asymptotes here, I always have to look at the exponents, or the degree, of each of my terms. In this case, they're equal. They're both 1. So if they're equal weight, you're going to take the ratio of the lead coefficients. In other words, you're going to divide the coefficients by each other to get your horizontal asymptotes. In this case, it's 1/2. Whenever you have a horizontal asymptote, we're not going to have to worry about an oblique. We'll get to obliques tomorrow. So just like before, vertical asymptote runs into your domain. So whatever that value is, it's everything but that. My range is the same idea. Take my horizontal asymptote, everything but that. So, your task, whether you choose to accept it or not, it's just not even an option here. Your task here is going to be, I've got it written on the sideboard. I didn't make it to the backboard for this one, but it's also on the website if you needed it. It's on 543, 11 through 14. We'll jumbo size this a little bit. 16, 18, 24, if it ever comes back into focus. Here it comes. 26, why are you going the other way? 32, thank you. And 36. There's 4 graphs in that whole thing. And again, just find your asymptotes and just plot a couple of points. Don't make this tough. But again, with only 10 problems, nothing too bad. Tomorrow we'll finish off the